Alright, we're going to try this again. I had some issues with my pen. Alright, what we have here is a percent yield problem, and we are starting with 56.9 grams of WO3, and we're making 42.8 grams. So first of all, the percent yield formula is percent yield is equal to experimental over theoretical times 100. So we need to know what the experimental is and what the theoretical is. Well, in a percent yield problem, the experimental is always given. So we know that's going to be 42.8 grams over the theoretical. Well, to calculate the theoretical, we do dimensional analysis. So anytime you actually do the dimensional analysis, that's when you calculate the theoretical yield. So we'll take 56.9 grams of WO3. We're going to convert that to moles, so we'll put grams in the denominator. And if you add up the molar mass, you get 232 grams of WO3 per mole. And then we want to go from here to here, so we will put moles WO3 in the denominator, moles of W in the numerator, and it is a 1-to-1 ratio, so that's always good. And then we will go 1 mole of W is 184 grams. So when we do all of that math there, we get 45.1 grams. So that is going to be our our theoretical. Times 100, and we get 94.9%. Alright, let's move on to the next one. Let me advance the slide. Let me clear, and let me get a pen. Okay, so this one says determine the percent composition of magnesium nitrate. So if it doesn't specify a specific element, then finding the percent composition means find the percent magnesium, the percent nitrogen, and the percent oxygen. So we do this using molar masses. So the first thing we want to do is add up the molar mass of that whole compound. So we have 24 for the magnesium, 2 nitrogens, 2 times 14, and 6 oxygens. So when we add that all up, we get 148 grams per mole for the whole compound. So to find the percent magnesium, we have 1 magnesium, which has a molar mass of 24, over 148 times 100, and we get 16.2%. We're going to do the same thing for nitrogen, but we have 2 nitrogens in the compound, so we'll do 2 times 14 over 148 times 100, and that will give us 18.9%. Now we could add up these two percentages and subtract from 100, or we could just do the same thing that we're doing. So we have 6 oxygens over 148, the total, times 100, and that gives us 64.9%. And those percentages should add up to 100%, or pretty darn close to it, like 99, 101. Either one of those are fine. Alright, so let's move on. So let me advance the slide. Let me clear, and let me get a pen. Alright, now we're trying to determine the percent water in this compound. And if you remember these are called hydrates. So it's a compound that contains a certain number of water molecules. Well, if we want to know the percent water in that compound, we're going to find the molar mass of water. So 2 times 1, which is hydrogen, plus 16 is 18, and we have 5 of them, so 5 times 18, over the molar mass of the whole compound. So copper is 64, sulfur is 32, we have 4 oxygens, each at 16, and then don't forget the water part. That's what people tend to forget with these problems. So when you add that whole thing up, you get 250. And then if you do all that math, you're going to get 36%. So this compound is 36% water. Okay, let's move to the next slide. Let me do some advancing here. Let's clear that out and get a pen. Whoops. Sorry, same slide. Alright, there we go. Alright, so now we want to find the empirical formula. And if you remember from way back when, you take your percentages and write them as grams. So 40 grams of carbon, 6.67 grams of hydrogen, and 53.3 grams of carbon. Well, we're not going to worry about why we can do that. We discussed that earlier in the year. Right here we're just going over the problems. So we want to convert these to moles. So the molar mass of carbon is 12 grams per mole. Molar mass of hydrogen is 1 gram per mole. Now don't treat hydrogen as a diatomic. It's part of a compound here, so we're going to figure out what its subscript is. Same thing with oxygen. We're going to use 16 grams per mole instead of the diatomic form 32. So when you do this math, you will get 3.3, 6.67, and 3.3. So then once you have these numbers, we need to make them a whole number ratio. So the easiest way to do that is to divide all of them by the smallest. So 3.3 is our smallest value, so we get 1, 2, and 1. So our empirical formula is carbon 1, hydrogen 2, and oxygen 1. To find the molecular formula, we need to do two things. You have to be given the molar mass of the molecular formula, and here we're given it as 150. And then what we're going to do is add up the molar mass of the empirical formula. So 12 plus 2 times, whoops, I might be having some pen issues again. 2 times 16, that's going to add up to be 30. So we're going to put that 30 there, and if we divide those two things, we get 5. So then what we're going to do is multiply everything in the empirical formula by 5. So 5 times 1 is 5. Come on now. 5 times 2 is... Alright, I'm having some pen issues again. Alright, this happened the last time. That's supposed to be H10, and then the oxygen is 5 also. Alright, I'm going to have to pause this and start again.